Welcome everybody to PTP's Lunch and Learn session. Today we're talking about building blocks for leveraging AI and life sciences. And our guest today is Micah from PTP. Micah, thank you so much for joining me.
Oh, thank you.
Okay, Micah, in true fashion, I actually have two questions for you to start things off. I have a dad joke for you, and then I actually have a question for you that was presented. Are you ready for our dad joke?
Probably not, but I think I'm going to get it anyway.
That is right. All right. So, Micah, did you hear about the restaurant on the moon?
No.
Well, they have great food, but no atmosphere.
Yeah, well, that qualifies as a dad joke.
Definitely. Okay, my last one, and this is actually a question that was presented by our quote unquote audience in the background. I heard you have a unique license plate.
Oh, yeah. Run for beer.
So he has RN, the number 4, BR.
Hey, you got to have priorities.
I like that. In fact, I didn't even know the answer when it was presented. Go to. All right, Mike. So we only have 15 minutes, well, 14 after all that. Let's start talking about some of these building blocks for AI. What are the main building blocks?
So for most AI, there's basically kind of four major building blocks that you're going to have. Data. You got to have something, some form of data. The actual like models, your machine learning, your algorithms. You need computing power, some kind of compute force to do all that, and then you're going to need some humans, some human expertise. Someone's got to know what they're doing and what you're actually trying to train it to do, and to do some validation of that. I'd say those are probably the main four ones. You could easily throw in intent is kind of a big one, and I think a lot of this gets overlooked with a lot of companies. AI is just another tool, kind of in a toolbox that largely in this cloud world is very overflowing already. Um, so you got to know what you want to do with it. Like it doesn't help to just generically say I want AI. Like um, having a vision, and kind of a concise target that you're going with. It's pretty helpful there also.
Mike, I think that should be number one. Your intent before you go to the data, the compute, before you even involve humans fully into doing the AI as a human, you need to understand your intent on using AI for life sciences, why you want to do it, what is the outcome you're looking for, and then you apply all the building blocks.
Yep. Yeah, I mean, you mostly have four kind of like a couple different drivers for AI. It's either like chat integrations or like customer integrations to kind of do those kind of the chat bots, the assistants. You've got productivity improvements, things like your co-pilots and your stuff to help coding and write scripts and improve productivity and performance. And then you've got like all that insights and the business insights, like how do you take that data, like really delve into it, find needles in a haystack and stuff like that. So it's best to like to know which one of those you're going to angle for before you start.
Mike, talking about AWS specifically, because that's like one of the top users and one of the top places people are utilizing AI. How they actually associate with some of the AWS tools like Bedrock, SageMaker, or even just the initial one of S3?
Well, I mean, you can kind of pull all those like blocks apart. You've got your data, and so that's going to be a large swath of services in AWS. S3 is a pretty big building block there. Um, Even RDS, even your Dynamo, your NoSQLs, your data lakes, even how you get glue to transform data into that. Are kind of all tool sets that you would be using for how you store data, how you control it and replicate it. Um, you know, then you get into like your actual language models is where you're going to get into SageMaker, you're going to get into Bedrock, depending on if you're kind of more API integrations or whether you're doing like machine learning from an end user perspective, which gets a little more into SageMaker that you'd be using. Um, Computing, that's kind of the bread and butter of cloud all over the place. Obviously your EC2s, but you can have ECS clusters, big Kubernetes clusters. There's all kinds of stuff using lambdas, actually just using like kind of more serverless stuff to either orchestrate or tie all this together or to actually do some of the work. Um, so that's mostly kind of how you get with some of the AWS services in there. You can get more into that. Amazon Q, is their kind of implementation of some parts of that. But those are mostly the services and the tools you'd be initially looking at. That's where you're going to kind of start your journey in that area.
Micah, all the variations of tools that are available from AWS, it gets really complex to kind of understand how they all work together. How do you really decide which ones you're going to be utilizing and the efficiency, and based off the outcome, how do you want to implement them?
I mean, this goes back to this intent idea. Like, you've got to know what you're going to want to do and how you're going to accomplish that. And then from there, your first biggest decision is going to be data, like, and how you manage that data and structure that data. So without good data, nothing else really works very well. Like, a model trained on bad data is just bad. And even a model trained on good data that is too narrow will never be useful in like large predictive situations. So you need both a quantity of data and a quality of data. Um, and so that's one of the biggest things that you're first going to get into is a data management strategy. How do you keep data? How do you preserve it? How do you maintain validity of data? And so that data is verifiable. It's not repeated. Like, you don't want like large duplications of data, and you don't want bad data mixed in with good data. Like, you're gonna need to help keep that all separate, nice and clean.
I'm assuming that's where the building blocks of the human aspect comes into it, and to understand the data and the output that comes out of it, and to make sure that your data is valid and the data that actually is going into it is not too narrow in concept.
Yeah, I mean, you're certainly going to need this human expertise to start identifying the data that you want grouped together that looks like that's good data. That especially when you get into SageMaker and all the stuff, and you're starting to train that model, you're going to need to train it towards a good set of data, and then have human expertise that kind of guides that decision. I mean, all of this is just like humans like are just using data to train some of these machine learning algorithms um, on big computers to solve a specific task. So you've got to get that human part right. Like, that's always going to be a big foundational point, and they will help. That's going to help you direct your data strategy. It's going to help you then to determine which algorithms you want to use. What's the most efficient way to use that computing power, um, and then that leads you into that task you were going to solve. Um,
When we were talking about the AWS tools, obviously Bedrock, Q, SageMaker, S3, Lambda, are there any that are more important than others?
well, we kind of hint on it before. Like, data is going to be the one that gets you pretty much off the bat. A lot of people want to kind of jump right into this generative AI, and they've got a lot of data, so it's sitting in places. They've never used Bedrock, and they've not used SageMaker, so those are pretty clean environments. Like, they haven't touched any of that stuff, but you've got this big bulk of data that has to be cleaned through. So that's probably the easiest place to start. Is to establish from a company perspective a good data management strategy, life cycle, how you organize data, how you isolate data, how you keep data clean, where's raw data, where's computed data, what's the data you're training on. Um, that's probably the biggest first thing is to have a good you know data management process and a cycle, because from there then you can easily transition a little bit more into actually doing the AI, doing the machine learning and the algorithms, because then you can do some trial and error and try some different things, but you've got this good data to fall back on. If your data is all messed up and it's all out of sorts, you might be training models and doing all this great work and never getting the outcomes that you're kind of expecting, because foundationally it's kind of messed up. In addition to that, computing power is a little overlooked, but it's out there, and you're going to need to make sure that that is, kind of well established. It's generally recommended that you would run through some kind of a well architected framework in AWS so that all of your networking and your security and how that all interplays and interconnects with each other is all well established and meets some of those standards, so that you don't start running into oddball things like that if it can't access data, or machines and compute cannot talk to each other, and you're just running into security stuff, or just opening up kind of vulnerabilities or just risks to your company as you're producing all this data that is just could be everywhere, um, if you not have it very well controlled.
Micah, that kind of goes back to the original building blocks that you were talking about, and understanding obviously the intent, the humans, the data that's coming in there. You started talking about getting started. Like, what should things that I take into consideration before I try to implement any type of AI for my life sciences? The processes, have those in place, but doesn't a lot of that stuff kind of slow you down if you need to go fast, not only for startups or proof of concept and everything for life sciences?
It doesn't if you've done it well, or if you know this is an intent. So if your intent as a small company or a startup is to go down this thing, would be to reach out, PTP, AWS, plenty of the companies can help you design these data strategies from the start. It doesn't take any more effort to put data in the right spots and to move data around in a controlled manner. It's just a little more planning, like to get that. And if your data is in a really weird spot now and you want to start getting to AI, there is plenty of tools that can help. You can use Glue, you can use stuff to crawl through that data sources. You can use some automation, some serverless stuff to try to move data around, try to get it in a good spot. But it is easier if you start that way. If you start how you intend to carry on, so you can collect all the metadata that surrounds that data, because there's just going to be raw sequence data, genome data, and all that other stuff. There's a lot of metadata that's around that, and you want to be able to capture that and have that well associated with those that raw data, so that way these models can take that and learn and really grow.
Before, you mentioned that compute is one of the things that are overlooked for AI implementation. What did you mean by that?
I think it's just an assumed in AWS, like, oh, I just run SageMaker, I just run this, and I'll just spin up instances and they'll just go. And that works to a certain point, but once you start getting into like real detailed models and you're using some of your own software and you want to run these calculations or these analysis tools, you're going to need to make sure that those images that are out there are running the software that you want, that they're hardened, that they've been, kind of controlled, like and tweaked to make them really fast. Like, you want as much efficiency as you can. When you start spinning up hundreds or thousands of CPUs, you don't you don't want a job that takes 5 minutes to do something when a well built machine could do that in like 30 seconds. There is a huge amounts of disparity between the different GPU sets that are out there for different stuff, even between the CPUs, how much memory they use, how fast they use it, how much processing power, threads, all that stuff. And all those can serve in different niches. And you can also use Spot, like you get into the instance of Spot instances versus just on demand to reduce that cost, because at some point cost is going to become a factor.
Micah, not only the compute is overlooked, but the cost is overlooked when associated with AI in any aspect of it, including life sciences and the implementation. Micah, I got to wrap things up. This is just going to be a quick 15 minutes on it. Thank you so much for joining me for this PTP's Lunch and Learn session.
Thank you.
Well, everybody, once again, this has been PTP's Lunch and Learn session around the building blocks of leveraging AI in life sciences. I was your host, Jon Myer. Joining me was Micah from PTP. Don't forget to hit that like, subscribe, and notify, because we're out of here when I click that button once and again.